Guys, I'm going to do a quick review over the worksheets because there'll be a test in biology on this Tuesday um, over elements, compounds, and mixtures. And I kind of want to make sure that you have the correct answers to the study guide and kind of hit the highlights once again to have you ready for the test on Tuesday. It'll be in Google Forms. You need to have it completed by Tuesday night at 11:59, please. And also, this is for Monday. Make sure you do your week 2, day 1 daily attendance assignment so I can mark you present in gradebook. So, what I'm going to do is I'm going to take the document camera. I'm going to have to turn the actual camera and go to a larger view. So if you'll give me just a second so I can pick up the study guides for you. Okay. So the first one I'm going to go over, if you want to maybe do a split screen, or you can actually camera shot these if you want to make it easier for you. Maybe I can get it a little bit more so you can get more of the page in view. Perhaps that might help you a little bit, and forgive all the cords going everywhere. So let me move this down as much as I can so you can see everything. Okay, that will get that full page in there. Um, so with elements, remember that the elements are listed in the periodic table, and there are boxes on the periodic table. Each box represents one element, and an element is different from all the other elements because of the number of protons. The number of protons in an atom determines what kind of atom it is, thereby which element it belongs to. So, a pure substance is an element, and an element is considered a pure substance because it cannot be separated. It cannot be separated into another substance. So once you have carbon, a carbon atom, you cannot split that carbon atom, because if you do, you're going to split the nucleus, which means you're probably going to split the number of protons apart, and then you might end up with two atoms, one with two protons, one with four protons. And if you do that, then you're going to have helium and something like boron, beryllium or boron, whatever element number 4 is. So an element, and it would, and that would take a nuclear reaction to do that. So when we're talking about chemistry, we're talking about chemical reactions. So you're not going to split an atom chemically. So here, an element cannot be broken down or separated into another substance, and this is basically by chemical means. It would take a nuclear reaction to do that. So, for chemistry, when you have an atom, you're not going to be able to divide it chemically, and that's the smallest part of an element. So if you had a gold bar and you kept dividing it down and dividing it down till you got to the smallest part that would still have the properties of gold, you would have an atom of gold. Okay, so on the periodic table, the first 92 elements, numbers 1 through 92, are naturally occurring elements on Earth. After that, starting 93 and on, those tend to be man-made types of elements. And you need to know this number for the test. This here is also on the test. You need to know that an element is a pure substance because it cannot be further subdivided or separated chemically. You need to know that hydrogen is the most common element in the universe. Nitrogen is the most common element in the atmosphere. Now, because we're humans and we're pretty self-absorbed, normally we would think that oxygen is probably the most common element in the atmosphere because that's what we need to survive, but actually it's not, it's nitrogen. However, oxygen is the most common element in the Earth's crust because if you remember from before, I told you that sand, chemical formula silicon dioxide, there's a lot of oxygen, okay, in the Earth's crust, and it's chemically combined. It's not an O2 molecule in the gaseous form. It will combine with other elements to form different types of rocks and minerals. Okay. This here is on the test also. Each element has a unique set of properties that is different from the set of properties of any other element. And then also, what's unique about this is, gold's different from silver because a physical property is color. Gold is what we call, is a yellow, we name it gold, and the other stuff is silver. But some of the other metals, like aluminum, are also kind of a silver color also. So, but aluminum's different from silver in other ways. Um, so therefore, when we talk about properties, the elements have a unique set of chemical and physical properties that's different from every other element. There may be some similarities there, but they're not all exactly alike because that one proton difference between one element and one square and the next one changes that particular atom as well as the number of electrons too. Okay, so the next page, on the back page, you need to know that the smallest particle of an element that has the properties of that element is an atom. And it's basically the number of protons in an atom that determines what element you're dealing with. So elements are different from one another because the atoms of each element have a unique number of protons. So like if you have the box of hydrogen, which the symbol's H, it's going to have a whole number here. That is the atomic number, and that's also the number of protons. This number down here is like a 1.0079. That's a mass number. And I'll explain more of that for the next test. But then helium in the box is going to have a whole number of 2. That's because helium has 2 protons. It has an atomic number of 2, which means it has 2 protons. Hydrogen is different from helium basically because of the number of the protons, and the difference in protons causes them to have different and unique properties. Okay. All right, that's pretty much what's on the test. Now, this stuff here is not on the test. I was just explaining why elements are different from one another because they vary in the number of protons. So you're not going to have to know all this part here for the test. Okay. Going to the next worksheet, chemical compounds. A chemical compound is a unique substance that forms when 2 or more elements combine chemically. So the classic example here would be water. You hear water referred to as H2O, and that's because it requires 2 atoms of hydrogen bonding to 1 atom of oxygen to form a water molecule. If you added 1 more oxygen, H2O2, then you have hydrogen peroxide. So you get a compound when atoms combine chemically, okay? And once these atoms combine chemically, they no longer have, they take on a whole set of different properties. Remember that oxygen will burn, it's combustible, and then you have hydrogen gas. Well, when they're combined chemically and form water, water will extinguish a fire, okay? So the oxygen here loses its unique properties as a single element, so does hydrogen, and when they combine chemically, they take on new properties for that particular compound. Another thing you need to know is that a compound always has the same elements in the same proportions, or you may see the term ratio. Whenever you have water, it's always 2 hydrogen to 1 oxygen atom. If there's not a number written back here behind a symbol, it's understood to be a 1. 2 hydrogen, 1 oxygen. Hydrogen peroxide has 2 hydrogen, 2 oxygen. That's why H2O2 is a different substance than H2O. A compound always has the same composition. Water is always H2O, whether it's in water vapor, liquid water, or frozen solid as an ice. And as I've been saying, the properties of a compound are different from the properties of elements that form them. Oxygen's combustible, but when you combine it with hydrogen, water's not going to burn, okay? So when the elements combine chemically, this compound has different properties than the elements that individually make it up. The other thing you need to know is that the smallest particle of a compound, if you took a drop of water and you kept dividing it and dividing it and dividing it, eventually you would get down to the smallest particle that you have that still has the properties of water. You wouldn't chemically, before you chemically separate the hydrogen and oxygen back apart. The last sample where you would have oxygen combined with hydrogen, that smallest particle that still has the properties of water is called a molecule. And you need to know that. Smallest particle compound that still has the compound's properties. Okay. And then mixtures. You need to know that mixtures are pretty much physical combinations. And because they are physical combinations, they can be physically separated. On the CK12 handout that I pushed out, it talked about lemonade, that lemonade's a mixture. It's not a compound, because you can squeeze 1 lemon into a quart of water, add some sugar, and call that lemonade. Or you can squeeze 1 lemon into a gallon of water, add some sugar, and call that lemonade. Okay? So mixtures are physical combinations, and they can have different ratios. Another example of a mixture is a salad. And also the other thing about a mixture is the individual parts retain their properties. So with a salad, it's a heterogeneous mixture because you can see the different parts of the salad in the grouping, and the different parts also retain their own properties. The tomato is still a tomato. The piece of lettuce is still lettuce. That's a heterogeneous mixture. And you can have 1 tomato in a bowl of lettuce, or you can have 5 tomatoes in a bowl of lettuce. It can be in any ratio. Okay, it's not a fixed setting like a compound. So why is lemonade not a compound? Because you can have lemonade with 1 lemon or 2 lemons. There's no fixed proportions, and they're not chemically combined. And then also 2 other examples of mixtures are salad, muddy water. The difference between homogeneous and heterogeneous: a homogeneous mixture has the same composition throughout. So lemonade is a homogeneous mixture, because if it's mixed up and there's no sugar settling or no lemon particles settling to the bottom, then you have a homogeneous mixture. Salt water is a good example. If the salt's completely dissolved in the water, that's a good example of a homogeneous mixture. You can't see any particles sitting on the bottom. But if you allowed the water to physically evaporate, you would have the salt left over. It would not look like the same crystals that came out of the salt shaker, but it would be salt. Okay? A heterogeneous mixture is like a bowl of mixed colors of M&Ms or the salad. You can see the different parts, and they keep their own properties. You can often see the different parts, and they retain their identifying properties. Okay. Now, there's different types of mixtures based on the particle size. And that's another test question. There's 3 types of mixtures. There's solutions, suspensions, and colloids. So I'm going to flip over to the back here. You have another page that's pushed out to you, I believe. Okay, so a solution's homogeneous because you cannot see the individual parts of the solution. A solution has very tiny particles. It has very tiny solute particles that are dissolved into the solvent. They don't settle. And so it's a solution. And because you can't see the individual particles, it's a homogeneous mixture. And salt water is an example of a solution. The type of mixture with the next largest size, the next larger size of particles is a colloid. And a colloid is a homogeneous also, but the particles are large enough that you can see them, but they don't settle out. And an example of a colloid would be jello or milk. A suspension is a mixture, but it's heterogeneous because in a suspension you can see some of the different particles of solutes that are in the solvent, because a lot of times these particles are large enough that they will settle to the bottom. So muddy water is an example of a suspension. There's 2 parts to these mixtures. The substance that's doing the dissolving, usually water for a lot of things, is the solvent, and the solute is the substance being dissolved. And the thing about a mixture, I've already said, the particles are the parts of a mixture. They keep their own identifying properties. Okay. Examples of physical properties include boiling point, the ability to dissolve, particle size, and when components of mixtures vary in physical properties such as these, processes such as boiling, dissolving, or filtering can be used to separate them. This is not on the test. I was just reading that to you. Okay, so these are kind of the answers to the handouts. I hope going over them again kind of reinforces and gets you ready for the test on Tuesday. And you need to do the daily attendance assignment, and you need to have these turned in by Monday night, or start turning this stuff in when you get these completed. Test is Tuesday. And then we're going to talk about organic compounds, and also about a little bit of review about atoms, and talk about ionic covalent bonding. We're going to talk about carbon being an organic compound because it's present in all living things. And then either by the end of this week or hopefully next week, we're going to start talking about cells, okay, or microscopes. So that's where we're going, but we need to do a little bit more background on some of the chemistry. So when we start talking about other cell structures and stuff and reactions, we'll have a little bit of an idea of how that works with some basic chemistry. Okay, that's it, guys. So do your daily attendance assignments and try to get everything turned in.